Okay, so today we're going to look at section 1.9, which is inverse functions. So your regular function, your original function would be y equals x squared. Then your inverse would be x equals y squared. So to find an inverse function, you switch your x and y values. To find an inverse, yeah. And then you'd solve it for y. Okay, and there's a couple key characteristics of inverse functions that we should know. To represent an inverse function, we call that f of -1 of x. So we put a little -1 above the x, f of -1 of x. That's the inverse. And then when you do combinations of your inverse function and regular function, then you'll always get it to equal x. So f of f inverse of x will equal x, and f inverse of f of x will equal x. And that's how you know that you've got your inverse function correct. Okay, that's the way you verify your inverse function. So let's start by finding an inverse function. So f of x equals 4x. And this is the same thing then as y equals 4x. And I'm going to switch it to the y so that it's easiest for us to verify the inverse. Very good. We switch our x and y, so x equals 4y. And then we solve for y. So how would we solve that? Divide by 4. Divide by 4. So y would equal x over 4. So this is my inverse, which then I could rewrite as f inverse of x equals x over 4. Okay, means the same thing. Okay, so let's verify that that's actually our inverse. And to verify it, we have to plug one of them into the other. So I'm going to take this x to the 4th, and I'm going to plug it in for x into my first equation. So I end up with f of f inverse of x equaling 4 times x over 4. Because all I did was plug in my inverse for where my x is. So then if I simplify, this 4 and 4 cancel, so I end up with x, which is what we wanted. You know that it's a correct inverse if you end up with x at the end. Okay, so let's do another one. So we have f of x equals 8x. So this is like y equals 8x. So then our inverse is x equals 8y. So then if we divide by 8 and divide by 8 to solve for y, we get y equals x over 8, which means that f inverse of x equals x over 8. And to verify it, we plug it in. So f of f inverse of x equals 8 times, we plug this in for my x, so 8 times x over 8. And then my 8's cancel, and I end up with just an x, which is what we wanted. So let's look then at graphing inverses. We're given the function f of x equals 2x minus 3, and we want to graph that. There's a couple different ways we can do that. We can try to solve this we can try to find our inverse and then graph that function. Or we can make a table of values for my first graph. So -1, 0, and 1. And then I can translate that for my inverse function. So let's start by finding these. So negative 1 plugged in, 2 times negative 1 minus 3 is negative 5. 0 plugged in, 2 times 0 minus 3 is negative 3. And 2 times 1 minus 3 is negative 1. Okay. And then our inverse is just our x's and y switched. So this would become negative 5, negative 1. All I did was switch them. Negative 3, 0. And negative 1, 1. So you just switch your x's and y's. So then when we do that, if we go to graph it, negative 5, negative 1 would be right here. Negative 3, 0 would be there. And negative 1, 1 would be here. So my inverse graph looks like this. Which makes sense because if I graphed my first graph, it would look like this. So then you can tell the difference. Okay, so let's do one more of those. F of x equals 4x minus 1, and we want to graph f inverse of x. Well, I know that my 4x minus 1 graph is going to look like this. That's going to be my original function, so let's make a table of values for that. So at negative 1, 4 times negative 1 minus 1 is negative 5. At 0, 4 times 0 minus 1 is negative 1. And at 1, 4 times 1 minus 1 is 3. So then if we translate those for my inverse function, I end up with negative 5, negative 1, negative 1, 0, and 3, 1. So negative 5, negative 1, negative 1, 0, and 3, 1. So my inverse function would be in the blue. So f inverse of x and f of x. Okay. So to figure out if a function has an inverse, we use the horizontal line test. To figure out if a graph was a function, we use the vertical line test. To figure out if it has an inverse, we use the horizontal line test. And you'll notice that it looks like I spelled if wrong, but I promise I didn't. This says that a function has an inverse if and only if it can pass the horizontal line test. That's how they abbreviate if and only if in math. You'll see that a lot in Calc. They'll put IFF because it stands for if and only if, which means that it has to be a one-to-one function. Just scrolling down. It'll be okay. Okay, so let's actually test a function for the horizontal line test. So we need to figure out if this graph has an inverse. So I pick any point on my graph and I draw a horizontal line across it. And then I count how many times it crosses the graph. So in this case, it only crossed it once, which means that it passes the horizontal line test. It cannot pass more than once. Since it only passes once, it passes the horizontal line test. So this does have an inverse. Because it's a one-to-one function. So it does have an inverse because it passes the horizontal line test. Okay. So let's look at 5b. We have this parabola x squared minus 1. That's what the function is. We need to test if it has an inverse. So we check how many times it crosses. It crosses more than once, so it does not pass the a horizontal line test, which means it does not have an inverse. So checking to see if it has an inverse is pretty easy. Just draw a horizontal line at any point on the graph and see how many times it crosses. Crosses more than once, it does not have an inverse. Okay, so that's what you guys are going to be doing today. You're going to be working on page 98, 7 through 10, 23 through 24, 39 and 40, and 63 through 68.